Hello guys, this video is for Unit 2 Functional Anatomy. We are looking at topics related to the muscular system, and in particular we are looking at the three types of muscle contraction that you're required to know. And you could be asked short answer questions on this, but this is also an essential part of your question 12 application when you do the movement analysis. So the specification requires you to know about these three types of muscle contraction: isometric, isotonic concentric, and isotonic eccentric contraction. So let's have a look at those one at a time. So here we've got some images of examples of isometric contraction, and these positions are all being held still by each of these athletes. So we've got a side plank, a glute bridge on the top here, so this athlete's holding that, suspending not only his body weight but the weight as well. We've got this sort of back arch saucer shape, commonly done in yoga, and we've got this sort of crucifix shape with a pike position in the body. Again, in gymnastics, you can see it's a ring skill for the Olympic gymnastics. So all of these athletes, as I said, are not moving. They are maintaining this position whilst remaining static, and there are muscles that are working isometrically to enable them to remain in that static position. So let's have a look at what isometric contraction means. So first of all, we can break down the name. The iso part of the name stands for same, and the metric part of the name stands for length. So you can see that the muscle, when it's contracting, is remaining the same length. And that's an important detail that you need to know. Now, I've tried putting this information sort of in a table. The blue stuff is essential cake information. The red stuff is really additional icing knowledge. If you can get your head around it, that's great to throw in and show off. Especially in your question 12, you're not likely to need it quite as much in your short answers. So the questions we have to ask ourselves when we look at what is a muscle doing, how is it working, is it contracting, what type of contraction is it, are these the sort of headings up here. Is the muscle, does the muscle have tension? So the fact that all three of these examples are contraction examples means that yes, the muscle is tense because it is in a type of contraction. During that tension, during that contraction, is the muscle length changing? Is it getting shorter or longer or not? And in the example of isometric contraction, no, it's not. So over here, this person is holding a dumbbell. It tells you there is no movement. And what that means is their bicep brachii is contracting to work against gravity. So gravity is trying to push the arm and the dumbbell down. And this bicep brachii muscle is opposing that force and equaling that force and applying enough force so that the dumbbell stays sort of horizontal at a right angle there. So is movement produced? No, the position is static. The athlete, certainly in terms of this muscle, is not moving. Now, other muscles might be creating movement, but whatever this agonist muscle is, it is not creating movement while it contracts. A little phrase that is good to learn, the sort of thing you can write in your answers, is there is no change in length under tension. So whilst the muscle is under tension, there is no change in length. That just combines those two. So in summary, isometric contractions have tension. The muscle is tense because it's contracting. However, despite that tension, there is no change in length of the muscle, which means there is no movement. The movement would only happen if this insertion was moving, was shortening or lengthening, okay? So if the muscle is the same length, there's going to be no change in position, no movement. And the icing content of this, typically speaking, not always, but can often relate to the up and down movements that we might do. And this is one, you know, during a bicep curl, the dumbbell would move upwards or downwards. In this instance, we've got gravity moving down, we've got the biceps muscular force contracting to pull the arm up, and those forces are equal during isometric contraction, i.e. there's not one that's bigger than the other, so the position is held static. And we can represent that by the arrows up here. So gravitational force is always downwards. Muscular force is always going to be the upward force in these up-down movement phases. And you can see by the length of the arrow that these are in fact equal forces, and that means there's no dominant force, no net force one way or the other, and there'll be no movement. Looking at isotonic concentric contractions now, these are different. So the first one, isometric, is always going to be about no movement occurring, whereas the other two do involve movement and do involve change in length of the muscle. So an upward phase of this barbell curl, okay, the upward phase, biceps brachii is contracting, pulling on the lower arm and making the angle at the elbow reduced, as in flexion is happening. So let's look at two joints in this example. So we've got the elbow joint, which in the preparation position is flexed. In the execution phase of a shot, it becomes extended. And the agonist muscle to do that would be the triceps brachii on the back of your upper arm. And that contracts concentrically to straighten your arm. But we can also look at the wrist. The wrist is extended in the preparation position, and it becomes flexed during the action where you flick the ball away. And it would be the wrist flexors that contract concentrically to do that action. Over here, we've got the upward phase of a press up, and the agonist muscle would be triceps brachii, which would shorten to basically extend the elbow, to straighten the arm, to push your body upwards. Nothing else changes apart from extending at the elbow joint. Actually, all of your abdominal muscles here and your leg muscles are probably contracting isometrically to hold your body still, and it's just your elbow joint that does the work to push you upwards. Here we've got a shot putter. So let's just look at again the elbow joint to start off with. So it's flexed in the preparation. During the action, it becomes extended. It would again be triceps brachii contracting concentrically to straighten, to extend the elbow joint, to project the shot put. But you could also look at, let's say, the knee. The knee is a little bit flexed in preparation. It'd probably be more than that in reality. This diagram's not brilliant. And obviously during the throw action in the execution phase, it becomes more extended. So the quadriceps, rectus femoris being one of those, would contract concentrically to straighten the leg at the knee, to extend the leg at the knee, and help generate force to push away. So there's lots of examples there of concentric contractions. Some are sort of distinctly up-down actions, and these two are not really that. They're not designed to be that. They are normal sporting actions, and that's a key thing. So let's look again at their table and what isotonic concentric contraction means, because if you have a short question on this, you'll probably need to tease out this information. Is there tension during this muscle contraction? Yes, of course, because it's a contraction, so there is tension. Does the length change during this contraction or tension? Yes, the muscle shortens. So here's our biceps brachii at right angle. During the upward phase, shown on the right here, the insertion, the tendon inserting into the radius and ulna, is pulling that bone. So the muscle force shortens and pulls upwards. So you can just about see on this diagram, we've got a longer muscle there and a shorter muscle there. So during concentric contraction, the tendons get closer. Maybe that's a way of remembering it. Concentric, the tendons get closer. Specifically, the insertion gets closer to the origin. So the tendons get closer, concentric. That would be lovely icing to put in your work. So what I've missed out is that iso means the same as we know already, and tonic means force. So during this upward phase, this biceps brachii generates the same amount of force at every angle during that upward phase. So same force or same tone. So is there tension? Yes. Does it change in length? Yes, it does. It shortens. So we could phrase that as the agonist shortens under tension. That's a nice way of summarizing both of those. Does movement occur during concentric contraction? Absolutely yes. So All of the examples that I showed you before show that movement is occurring, definitely on the up phase stuff, but most of your sporting actions, kicking a ball, standing on tiptoes, all are concentric contractions. The majority of sporting actions will be concentric contractions. So if it's up, specifically up phase, it is, but most other contractions are concentric. Now, again, looking at our icing forces information, this is, again, really only related to up-down movements. So we could use this biceps brachii as an example. In order for this athlete to move the forearm upwards, he's got to generate more muscular force which is an upward force, than the downward gravitational force. So remember, gravity is constant, it never changes, it's a constant downward force. So if I want to move the dumbbell upwards, I've got to generate a bigger muscular force than the gravitational force. So here we have something that just symbolizes the muscular force is bigger than gravitational force, and that is concentric contraction on the up phase of certain movements. Lastly, let's get on to isotonic eccentric contractions. So again, this is a same tone type of contraction, and you'll see the difference. So we had previously, this middle one here, we had the up phase, which was concentric. However, the same muscle group is the agonist on the downward phase of this barbell bicep curl. On the downward phase, gravity is desperately trying to push the bar downwards and accelerate the bar downwards. Well, we don't want a rapid, out of control downward phase, because we're quite likely going to damage our muscles and tear some muscle fibers. So what we want to do is lower the barbell with control. And that phrase is a lovely one for you to make note of and hold on to. So on downward phase movements, which is really only what you're going to have to talk about eccentric contractions for, downward phase movements, we want to lower with control, which is why our muscles work in a slightly different way. So during that downward phase, that biceps brachii is contracting, but instead of getting shorter, it's getting longer, so that it lowers the barbell with control, gently extends the length of the muscle to control the downward phase. The same would apply of our other example, our press up. So the triceps brachii in this example was the agonist working concentrically to straighten the arm to push the athlete upwards in the up phase. However, in the downward phase, gravity is desperately trying to push this person to face plant on the floor, but we don't want that to happen. We want to lower with control. So our triceps brachii works in a different way, contracts in a different way to gradually control the rate of us bending our arm. I do not need my biceps brachii to bend my arm. Gravity is trying to bend my arm. I need my triceps brachii to slow and control the downward movement. Let's put that into the table then. So, is there tension during eccentric contraction? Absolutely yes, it's a contraction. Is there a change in length during eccentric contraction? So let's look down here, over here, the downward movement. We've got our neutral length, our starting position. As the barbell is lowered or the dumbbell is lowered, you can see that the length of biceps brachii, it gets longer. So it does lengthen, it changes length. And it changes length. We could describe it as this insertion is getting further away from the origin. So, tension, yes. Change length, yes. It lengthens during contraction, lengthens under tension. Does movement occur? Yes. If the muscle changes in length, it's going to cause a movement. This is downward phase movements only. Okay, this is downward phase movements only. So if you have a short answer question that says, during the downward phase of something, you know it's going to be talking about the eccentric contraction, and you just need to figure out what the agonist is. These are the phrases. This agonist will work in this way so that we can lower with control, and it acts as a brake, almost like to slow us down. So let's look at the relationship between the forces. This is icing again, so if you can't get your head around this, don't worry too much. We've got downward gravitational force, we've got upward muscular force. Now we actually want the movement to go downwards. So we want ultimately our muscular force pulling up to be a little bit less than gravitational force pushing the barbell and arm down. So it's really important that it's only a small difference between gravitational force and muscular force, so that it is lowered gently with control and slowly. If there's a big difference, i.e. gravity is high and muscular force is really small, then the barbell will fly down towards the ground and you can obviously pull your muscles. So in this example, I've put a small triangle to try and represent that. Ultimately, we want the muscular force to be a little bit less than gravitational force, therefore the movement goes in that direction. Here's a couple of diagrams that give you all three types of contraction to give you context. Have a little look at that. And again, here's a summary just to put them all together so you can take a moment and compare the differences. So there have been 2 exam questions that are short answers on this topic. Remember, you will always have to talk about type of contractions in question 12. So you must learn it for that purpose. But also you can get a short answer question. Here's one for 3 marks. What type of contraction is being used to hold the position? So you may have done at school a wall sit. And the mark scheme says it's isometric contraction for 1 mark. Because in this type of contraction, the muscle develops tension, 1 mark, tick, but there's no change in length of the muscle, tick. So that basically is the table that you will be learning. Here's another example. Explain how eccentric contraction allows movement at the elbow joint during the downward phase. Downward phase, they've told you it's eccentric contraction for the press up at the elbow joint. So we know it's going to be triceps brachii. Here's our answer. During the downward phase, the triceps eccentrically contract. They are the agonist. They lengthen under tension and they control the lowering body. And then we have it.